everybody, let's sketch this graph of this hyperbola like we'd learned in the lesson before. Mateo, I'm going to take your question in just a little bit. So on Wednesday, guys, we spoke about, hyperbolas. Yes, we spoke about hyperbolas. And we said that this number over here, this -1 over here, is our y asymptote. And x cannot be something. For those of you who remember, y cannot equal to -1. What can x not equal to? You can pop that into the chat for me. Hi, Nell. Hello, my sweetie. Excellent. Yes, the answer that x cannot be is 0. Good. Hi, Ursula. Oh, I'm loving seeing everybody today. X cannot be equal to 0. Excellent. So we know that we've got an asymptote at x cannot be equal to 0 and x cannot be equal to -1. So those are our asymptotes over there. Mateo, don't put your hand down, my sweetie. I'm going to have a chat with you just now. Okay. Okay. All right. Then we know that because it's positive, because our function is positive, which two quadrants will this lie in, guys? If it's positive, what are the two quadrants that my graph will land in? Hello, Tinswalo. My graph will land in which two quadrants for a positive graph? That's it, Kemotlotlo. Excellent stuff. That's it. It will land in quadrants 1 and 3. Well done. Quadrants 1 and 3. So when we draw our two graphs, they will look like that. They mustn't touch our asymptotes, and the other one will be down here, like that. All right. And then the question over here also says, find the x-intercept. And when we look for the x-intercept, guys, remember, y must equal to 0. Okay, y must equal to 0. So we can make y equal to 0, or f of x. F of x and y are the same thing. So we're going to say 0 is equal to 2 over x minus 1. We will then take -1 over to the other side, and it will become +1. So I will have 1 is equal to 2 over x. And therefore, if I cross multiply, x will equal to 2. So this point over here, where the graph crosses my x-axis, will be the point 2, 0. That is my y-intercept. Right. Today we're going to be learning about exponential functions, and we're going to start with the sine, cos, and tan graphs. We're going to be doing those 4 graphs today, but we're only going to do an introduction to sine, cos, and tan graphs. But for now, we're going to be looking at exponential functions. Now, exponential functions basically just means that our x value, or our input value, will be in our exponent. Okay, it'll be in exponent form. Now, when we look at our exponential graphs, guys, we're going to consider the same things, kind of the same things that we do when we consider the hyperbola. Okay, the first thing we're going to note is that our exponential graph has an asymptote. Okay, it has an asymptote as well. Okay, now when we look at this asymptote, it's going to be this number over here, and this number is always going to be our y asymptote. Okay, now one thing that we have to note before we continue is that this number over here, this number here in the middle, we normally in a graph, okay, our heading under theta is exponential functions. Okay, when we're looking at this number in our graph, we normally call it b. If they give you a formula and they don't give you the graph, they'll do this. They'll go f of x is equal to a times b to the power of x plus q. Now this value b, which I've put here as 2, I've replaced my b over here with 2, cannot be equal to 1. Okay, it can't be equal to 1. Because if I have a graph that says 1 is equal to x, what are all my answers going to be, guys? If x is 2, if x is 5, if x is 0, if x is -5, what will my answer always be? Karabo, do you know? What will my answer always be if my b value at the bottom is always 1? Sure, Karabo's not unmuting. Okay, but you guys get the idea. The answer will always be 1. and we won't have a graph. We will just have a straight line. So we can't do that. Also, the B value cannot be equal. Oh, look at what I'm doing. B cannot equal 0. Okay. B cannot be equal to 0 because we're going to get the same issue again and again. 0 to the power of anything is just going to give us 0 again. So B cannot be equal to 1. B cannot be equal to 0. Okay. Also, you can't have 0 to the power of 0 because this is undefined. We cannot have 0 to the power of 0. 0 to the power of 0 is not 1. It is undefined. So we can't have B equals 0 either. Now, B can also be any number. B can be any number in between 0 and 1. So B can be equal to a half, or B can be equal to 1/3. No problem. But it cannot be 0 or 1. It can only be 1 or between 0 and 1. Any number in between there is fine. But the number 0 and the number 1 is a no. Okay, that's a no. Now, if we have to sketch the graph of B or of f of x is equal to 2x, let's start with just 2 to the power of x. Let's start with something simple. All right, if we have to sketch this graph over here, I just want to extend this a little bit. It's a little too short for my liking. All right, if we have to extend this graph over here, if we have to draw it, we're going to pick one point, okay? We're going to note, guys, that I will never get a 0 on this side if I've got 2 to the power of x. If I had to look for 2 to the power of x is equal to 0, I'm never going to find a value for x. There is no value that will make this true. There's no value that will make this true. So in a graph that just has this b value over here, my asymptote here is equal to 0. Okay, where y is equal to 0, that is my asymptote. There's no value that I can put in here for x where I'm going to get the answer 0 out. So my asymptote is going to be here. This is where my asymptote is going to be, right? And then for an exponential graph, guys, the only thing I need to do is I can consider one point. And then I'm going to show you what the graph is going to look like. We're going to look at if x is equal to 0. So if x is equal to 0, I'm going to get that y is equal to 2 to the power of 0. What is 2 to the power of 0, guys? You can pop your answers in the chat. 1, good. Anything to the power of 0 is going to give us 1. So this value over here is going to be 1. So the point that we're going to cut through, guys, is that point there, point 1. An exponential graph will look like this. It will be coming from this side over here, going that way. And this is the graph of y is equal to 2 to the power of x. All right. Give me a thumbs up if the way we drew the graph makes sense. We needed two things, the asymptote and x is equal to 0, where x is equal to 0. Give me a thumbs up in the chat if what we've just done makes sense. We only needed these two things. These two things. Nolwazi and Mawande, if you give me a thumbs down, you need to explain to me where it is that I've lost you. Aseza, Atlechang. No, Kimutluklu, it is not a hyperbolic graph. It is an exponential graph. Okay. Guys, we are no longer looking at hyperbolas. We are looking at exponential graphs. Okay. If anybody is still lost, please pop a question in the chat, or you can even raise your hand so we can talk about it. Okay. Buntle, what's up, my sweetie?
Hi, ma'am.
Yes, my sweetie, what's up?
Ma'am, you know, like, I just want to tell you how we do it at school, and I just need you to explain why you do it this way, okay? So my teacher, the way she does it, she does, you see the fx equals to 2x. She tells us to pop it in a calculator, you see. And when we do it in a calculator, we also draw a table for it, you know. So it has like coordinates. I don't know if you do understand me.
Yes, I do. I absolutely get you. Okay.
So what actually confuses me is that the way without the numbers, how do you actually know that it's one, that it has to actually be there?
Okay, so what we've actually looked for, Buntle, over here is an x-intercept. Oh, sorry, a y-intercept. Okay, we've looked for a y-intercept. And when we look for the y-intercept, x needs to equal to what?
To 0.
Good, x needs to equal to 0. So in this equation over here, the one I'm highlighting in blue, I've made x equal to 0, and that gave me my y-intercept. Do you see that? It gave me that my y value needed to be 1. Now, because I know that if I wanted to find an x-intercept, I would have to make y equal 0. Do you agree with me?
Yes, I do.
Good. So I'm going to make this f of x part 0, and I'm going to get 2 to the power of x is equal to 0. Buntle, can we think of a value that is going to give us 0 if we put it in for x as an answer? Any number?
5.
If I put 5 in, I'm going to get 2 to the power of 5. It's going to give me 32, not 0. Any number. Even if I say x is equal to -1, I'm going to get 2 to the power of -1, which is a half. If I put in x to the power of -2, I'm going to get 2 to the power of -2 will give me 1 over 2 squared, which is a fourth. Okay, so we're not going to get any values underneath this line. You see this green line that I've drawn over here? Is that making sense, Buntle? Because I feel like you're gone now. Buntle, come back. Come back. Oh no, okay. So Anatita, you're making sense with that question over there. Setu, what's up?
Hey, ma'am.
Hello, my sweetie, what's up?
I just have a question.
Yes.
You see the first equation, you said f of x equals 2 to the power of x. Is it
Yes.
when will is our asymptote? How do you pronounce that word? Asymptote.
The asymptote, yes.
Is our asymptote 0 because we don't have like a plus something?
Yes, but we can easily just do this, Setu. We can go plus 0. What's my asymptote now?
0.
It's 0. Okay, but because there's nothing there, our asymptote will be 0. But the mathematics behind it is because we don't find a number that's going to give us 0. Okay.
Thank you.
All right, my sweetie. Okay, for those of you who are a bit confused, you can actually use a table. You can. But when we get to grade 10, grade 11, nobody's going to ask you to draw a table, guys. I can guarantee you, tables are things that we do in grade 9. We don't do them really. Okay, so if you know what the graph needs to look like, then we can talk about the points that we need. We're always going to need an x-intercept and a y-intercept. Those are the most important things. It doesn't matter which graph we're drawing, guys. We will always need an x-intercept and a y-intercept. Now, in this case, we know that if we take our y-intercept into account and x is equal to 0, the graph will turn here. Right. And if x is equal, if we're looking for the x-intercept where y is equal to 0, we're not going to get an answer. Therefore, that y equals 0 is our asymptote. So our graph cannot cross that horizontal line. Okay, but here's one thing that we can look at, guys. I'm going to quickly remove this. Okay, if I have to draw now the graph of f of x is equal to -3 to the power of x, my asymptote will still be 0 here. Okay, I'm going to change it up in just a little bit. My asymptote is still equal to 0, but what's happened to my graph now? If I put in the point x is equal to 0. Tell me in the chat, guys, what will my y value be equal to? Yes. Chifaro, you can find a y-intercept and an x-intercept for all of them. Nolwazi, what's up, my sweetie?
Hi, ma'am.
Hello, my sweetie.
Ma'am, I asked a question, but then I got kicked out before you could answer.
I'm sorry.
I wanted to ask,
Okay, can you just repeat your question for me?
why aren't there any units on the x-axis, just a line, and there's only one number, which is the number 1 on the y-axis?
Okay. All right, because we said that our y asymptote is at 0, right? And where y is 0 is on this point, I'm saying Chifaro, Nolwazi, which means this whole line over here becomes an asymptote. Do you understand what I mean? So our graph, okay.
So it has to start on, why doesn't it start on the 1, but it starts on the x-axis other than on 1?
Okay, on 1 we have an answer. Okay, so do you see how over here, Nolwazi, I've drawn a line that goes on forever? You see that it's going to keep going. It's going to go, but it will never touch this line.
Okay.
Okay, and in this direction, it's going to go up all the way to infinity. It's never going to get anywhere. Okay, but what we know is, even if this line over here, let me redraw it. Even if it does this and it gets super close to my asymptote, it will never touch. Okay.
Yes, ma'am.
Does that make sense?
Yes, ma'am. Thank you.
Excellent. All right, my sweetie. Hi, Didi.
Hi, ma'am. I have a question. So can our graph be like mirrored, as in like it starts from the other side?
Yes, this is what this negative graph is about. Okay.
Ma'am, I still don't understand.
Okay, all right.
I see how
Mm-hmm.
yours is moving from the bottom left corner, going up, going like to the right corner. Can it move like the other way, as in like from the right to the left?
So you mean the graph itself needs to move like that?
Yes, and something like that, like it's mirrored sort of in a way.
Oh, so mirrored like that.
Yes.
Oh, yes. And we're going to talk about that kind of graph as well in just a bit.
Oh, okay. Thank you, ma'am.
Okay. Okay, excellent, my sweetie. We're going to get there. That's just a graph of a half of something. Hi, Olarato.
Hi, ma'am.
Hi, my sweetie. What's up?
I wanted to ask,
Yes.
earlier on we said that x cannot be equal to 0. So what happened?
No. That was the hyperbolic graph. Okay, look at the difference. Okay, look at the difference between this graph. It's a hyperbola. Do you see how they're two different graphs?
Mm-hmm.
And down here, we're not talking about a hyperbola, my sweetie. We're talking about an exponential graph.
Oh, okay. Thank you.
All right, my sweetie. Okay, we're going to explain this question one more time, guys. Okay, so we're going to consider the graph of f of x is equal to 2 to the power of x, right? Now, for those of you who are used to using your calculators and doing your graphs, sure, you guys can go ahead and do that, okay, and use your tables. That's fine as well. Okay, we're going to focus on this graph quickly. Okay, let's focus on this graph of y is equal to 2 to the power of x. Now, all graphs, guys, apart from a straight line graph and a parabola, your hyperbola and your exponential graph will have an asymptote. They will have an asymptote. Now, the asymptote of a graph that doesn't have anything over here is y is equal to 0, or the asymptote is where y cannot be equal to 0. After we do this, guys, we're going to go look for a y-intercept. Now, tell me again, what do I need for a y-intercept? What does x need to equal to? Y-intercept? Good. X need to equal 0. Good. X needs to equal to 0. So we're going to go over here And we're going to replace x with 0. So we're going to get y is equal to 2 to the power of 0, and that is equal to 1. So where x is 0 here, y will equal 1. There's our point there at 1. Now, an exponential graph will normally curve, a positive exponential graph will curve in this direction, that way. Okay, right. And we can even test this, guys. If we use the point 1 over here, we're going to get 2 to the power of 1. If x is 1, 2 to the power of 1 is 2. If x is 2, we'll get 2 to the power of 2 is equal to 4. If x is 3, we'll get 2 to the power of 3, which is 8. Do you guys see how this graph is going up? It's going all the way up in that direction. Okay, give me a thumbs up if the positive side makes sense. Give me a thumbs up. Excellent, excellent. Now let's try some negative numbers. Okay, I'm only going to look for a few of them. Let's do this. Let's do, if x is equal to -1, I'm going to get 2 to the power of -1. And I know that anything with a negative exponent is just 1 over that thing. So at x is equal to -1, y is equal to 1/2. At x is equal to -2, I'm going to get 2 to the power of -2. This is the same as 1/4. Do you see how on this side, the numbers are getting smaller, but they're not equaling 0? Okay, they don't equal 0. They just keep getting closer and closer to the y-axis, but they don't actually get to the 0 point. The fraction just gets smaller and smaller and smaller and smaller. Okay. Okay, so the fractions are just going to get smaller, but we know that our graph cannot touch the y-axis at 0. That is our asymptote. Okay. Yes, Kama.
Hi, ma'am.
Hello.
Sorry, like I just noticed it now, but like, isn't the label of like the asymptote meant to be like on like the asymptote line?
You can, yes, absolutely. You can put the graph there. You can say that y is equal to 0. You can, okay, but in the case of the axes, I don't think it's particularly necessary. But if your teacher is going to be OCD about it, put it in. Okay.
Yeah, she is. Yeah.
Okay. Then put it in. Don't even play around with her. Just put it in there. Okay.
Sure, ma'am. Thank you so much.
Sure. All right. Somebody's asking, ma'am, can we draw it as a straight line? No, we can't, because it's not a straight line. It's curving. It's going up a lot faster. Okay. Oh, no worries. Sorry, Kabo. Okay. Yes, Mawande.
So ma'am,
Yes.
for the last question, y equals 2 squared by 0, right? It increases by
Yes.
like the x-axis, right? So if it's on -2 x, then it's gonna be
Yes.
-2 squared by 2. Or no, I don't think I'm saying it right.
No. You only square the number. Remember, Mawande, there's a difference between -2 to the power of x and -2 all to the power of x. There's a big difference. Okay.
Yeah.
Right. Same if I say -2 squared and -2 all squared. This answer over here will be -4. This one will be +4. There's a big difference.
Yeah.
Okay.
Yeah.
Okay. Does that make sense?
Yeah. Yeah, I think so. Yeah.
Okay, so in the next question, when we look at it, this one over here that says -3 to the power of x, we're going to look for the value of x, put that in, and whatever answer we get, then we're going to multiply that by negative. Okay.
Okay.
All right. Excellent. All right, Lesedi, what's up, my sweetie?
Hello, ma'am.
Hi, my sweetie, what's up?
Can I ask what is an asymptote?
Oh, an asymptote is the thing that our graph cannot touch. Do you see how our line doesn't touch this graph over here?
Yes, ma'am.
Yeah, so that's it. It's a point where we're either going to get something as undefined or it can't equal to that. That's the asymptote. It's a line that our graph is never going to touch. Okay.
Thank you, ma'am.
You're very welcome, my sweetie. Ututleng, what's up, my sweetie? You can unmute.
Hi, ma'am.
Hello, my sweetie.
So, ma'am, I was wondering if like the asymptote will always be equals to 0.
No. And we're going to look at another example now where the asymptote moves. Okay.
Okay, thank you, ma'am.
All right. Okay, excellent. All right. I just want to make sure everybody's okay with the way that this graph is drawn. Give me a thumbs up if you guys get what's happened on the screen. Okay, Anotita, in this case, we will, yeah, our horizontal asymptote will be where y is equal to 0 because we know that y cannot be equal to 0. Okay. All right, now let's look at the negative graph, guys. Let's look at the negative graph. Okay, I'm going to change this to -2 to the power of x. Now, guys, I know that my asymptote is still going to be at 0 because it's almost the same one as this one. The asymptote will also be y is equal to 0. Okay. Yes, Chiparo, it will always curve, always. Now, guys, I'm going to ask you, if x is equal to 0, what will y be equal to? Because I'm then going to get -2 to the power of 0. What will my answer be here? 2 to the power of 0 will give me 1, but there's already a negative in front of it. So what is my answer? That's it, Nolwazi. Excellent. My answer will be -1. So my y asymptote, where x is equal to, not asymptote, y-intercept, where x is equal to 0, will be down here. Okay, -1. Okay. So that's the point. Now, the way our graph will curve is this way. Our graph will curve in this way. Now, remember, our graph can't touch. Let me, guys, you know, I'm not an artist. There we go. Our graph will curve in this direction. Okay, because all of our positive values will just be negative, and all our negative values will just then become, actually, we won't have any positive values. Any positive values, they'll all be negative. All right. Yes, Buntle.
Ma'am, can we say that this graph is like a reflective graph?
Yes, it's reflected about the x-axis. Okay, so we're taking the x-axis, our horizontal asymptote, we're taking the graph from here and flipping it to this side.
Okay, and also, ma'am, I wanted to ask that when we do the exponential graphs,
Yes.
don't we also have the symmetry, the range, the domain, and...
Absolutely. Okay, we're not doing that as yet. Okay, we still have next week where we're going to be looking at interpreting graphs, and that's when we're going to focus on that. Okay.
Thank you, ma'am.
You're very welcome, Stephen. All right. Sibahle, how are you doing, my sweetie?
Thanks, and you, ma'am?
I'm good, thank you. What's up?
And I wanted to ask about the asymptote. Is it possible that it can be on 1 or -1?
Yes, and that's the next kind of graph that we're going to do. Okay.
Okay, thank you.
All right. Ms. Bache, like she missed it by like 10 seconds because that's the next thing I was going to do. Okay, that's okay, Moteo. That's okay. Go rest. Hope you feel better soon. Okay. Hope you feel better soon, my sweetie. We'll see you in the next class. All right. Okay, let's mix it up a little bit, guys. I'm going to do this. I'm going to go 2 to the power of x plus 2. I'm going to add a 2. Bye, Mateo. See you next class. Right. Now, what's going to happen here, guys, is that I'm actually going to erase everything, including my Cartesian plane. I'll add it again just now. Okay. All right, here's what's going to happen, guys. All right, so now if I have 2 to the power of x plus 2, remember that my graph is positive, guys. It's positive. So it's going to curve upwards in that direction. It's going to curve in that direction, right? Now my y asymptote is no longer 0. My y asymptote is going to be this number. Okay, my y asymptote is equal to 2. So we can go to the point 2 and we can put a thingy there and we can draw our asymptote. Okay. It's fine. You can draw them freehand. It's not that big a deal. Okay, as long as you understand what you've drawn. Don't be like me who can't draw this properly. Okay, so that is our asymptote guide now, guys. Now I'm going to say to you, I still need to find my y-intercept. So I'm going to make x equal to 0. If I make x equal to 0, what will my y value be now? What will y be? If x is equal to 0, I will get 2 to the power of 0 plus 2. How much is that, guys? Samkelo, where is that, a 2 or a 1? Oh, somebody's spamming us. Who's that? Who's spamming us? Anotita, careful, careful, careful. Okay, good. That's no problem. All right. Our x, oh my goodness, the y-intercept is going to be 3. Right. So now my graph is going to cross here, which means my graph will go from here. Remember, it can't touch my asymptote, so it will do this. It's a 2. It's a 2. It's a 2, Samkelo. My graph will do that. Right. I want to erase this quickly. The green line is on the green line is a 2, Samkelo. Nolwazi, what's up?
Hi, ma'am.
Hi.
Why has the line of asymptote moved up to 2?
Okay, because our whole graph, remember plus 2, what this plus 2 does is it takes our graph that was on 0 and it shifts the whole graph up by 2. That means our asymptote will also move up by 2.
So
okay.
2 represents Q on the
That's
formula.
It's the Q on the formula. Yes, it's the Q.
Oh, okay, ma'am. Thank you.
All right. You're very welcome. Muchidze, what's up, my sweetie?
Good afternoon.
Afternoon, my boy. What's up?
Ma'am, I'm confused, ma'am. These green lines, ma'am, what are they for, ma'am? The green dashes.
Asymptote. Okay, it's this point here, the 2. Okay. It's the 2 over there.
Oh. What
this means, Muchidze, is that remember what our graph looked like. Our graph was sitting here next to the x-axis, right? It was sitting over here,
yes.
Remember?
Yes.
What this plus 2 tells me is, basically plus 2 is saying, take your graph and move it up 2 units. Okay, but then our graph can't touch this line. Our graph must be above the line. Okay.
Okay. So, ma'am, let's say in the test, they ask me draw the plane. What if I don't do the dashes? Do I still get the marks correct?
Unfortunately not. The dashes are needed. They are the asymptote. You need to draw them. Okay.
Okay, thank you very much.
All right, no worries. Remufilwe, what's up?
Good evening, ma'am. I just wanted to ask about the 2. I just wanted to ask if it has an effect on the Q.
The 2 is the q. Okay, so the original graph would look like this. Ramufilo would go, y is equal to a times b to the power of x plus q. So in this graph that I've drawn over here, I've replaced the q with a plus 2.
Oh, okay.
All right.
Thank you, ma'am.
Okay, my sweetie. Okay. Olarato, last question, guys, because we're going to move on to the next question. All right, Olarato, what's up?
Ma'am, I wanted to ask me, so will the y-intercept always be x equals to 0?
Yes, always. Y-intercept x equals to 0. What about the x-intercept? What must we do? Y must equal?
1?
No, 0. Always. Always.
So
X-intercept, y equals 0. Y-intercept, x equals 0. All the time.
So, ma'am, is that just the formula?
Yeah, it's the formula. Common knowledge. For every graph. You can do it for every graph, Olarato. Every single one.
Okay.
Okay?
Thank you.
Sure. All right. Tenswalo and Karabo, I'm going to ask you guys to hold your questions for me for just a second. I want us to look at this graph over here. Now, I'm going to ask you guys, what is my asymptote for this graph? It's still 2. Do we all agree? It's still 2. My graph is going to move up to 2. But I know that my graph is negative. This time my graph is negative, guys. So my graph must face down. My graph must face down. Okay, my graph must face down. Okay, instead of up, my graph is going to go down. Now, yes, Mutluke, you did. All right. So if I now have to find the y-intercept, I'm going to make x equal to 0. What is y going to equal to? Guys, let me know. What is y equal to if x is equal to 0? Yes, Anutida.
Hi, ma'am.
Hi.
How are you?
I'm good, thank you, my boy. How are you?
I'm good. I just wanted to ask you, when are we going to state the domain and the range of these graphs?
That is going to be when we are doing the interpretation of graphs, which will come next week. Okay. So when they give us a graph and we have to find the equation, then we'll talk about domain and range. Okay.
Oh, and also how the other graphs shifts from left and right, and also how it reflects over the points in that. Okay.
Okay. So unless you're doing IEB, Anutida, then you like in grade 10, we wouldn't shift the graph left or right. In grade 10, we put it up and down.
Yes, I'm just talking about like plotting two graphs on one Cartesian plane.
Oh, yes. That is next week. That is next week. Okay.
That's what I was.
Right. Excellent.
Thank you very much.
All right. No worries, Anutida. Nolwazi, don't let them confuse you. We're only going to talk about that next week. Karabo, what's up? Karabo, you're going to have to unmute for me. All right, let's talk about this graph, guys. I know that my y-intercept is going to be over here at -1. Okay. Now, let's have a look at what's going to happen here, guys. Watch what's going to happen. That's how my graph is going to go. Do we notice something? What do we know about this point over here, guys? Didi.
Sorry, I'm not answering the question, but I have a question. Like people were saying -1, and when I put it in my calculator, like that whole sum, I got 1. So yeah.
It should be 1. It should, because -1 plus 2 is 1 and not -1. You're absolutely correct. Thank you.
So, okay, never mind. Thank you, ma'am.
So no, you're correct. You're correct. It should be 1. So it should be over here. Okay. So our graph should actually curve like this. Okay, what do we call this point over here, guys? I'll tell you what, my y value is 0 over here. Where do we know about where the y value is 0? When is y 0? I'll give you a hint. Y equals 0. Can you still beat me to it? Can you still beat me to it? That's it, Ritepile. Excellent. It's not going to be a turning point, guys. It's going to be the x-intercept. That's it. X-intercept, y is equal to 0. Now we have an x-intercept. So we need to calculate for the x-intercept. X-intercept, y equals 0. So we're going to go into our graph and we're going to make this part over here 0. Okay. So we're going to get 0 is equal to negative 2 to the power of x plus 2, right? So we're going to take the positive 2 over to the other side, and we're going to get negative 2 is equal to negative 2 to the power of x. What value of x do I need here in order for this statement to be true, guys? What does this value over here need to be? Not 0. Not 0, guys, because if it's 0, it's going to change this whole side to 1. Good. This value over here needs to be 1 in order for that to be true. Therefore, x is equal to 1. So our graph turns over here at the point, or our graph cuts the x-axis at the point 1, 0. Okay. Before we continue, everybody give me a number out of 10. How comfortable are we with the two different graphs we've just drawn? While I take Nolwazi's question.
Hey, ma'am.
Hi, my sweetie.
Why does the next line start on the green line and not on the x-axis? Why has it jumped the x-axis?
Okay, because remember this plus 2 over here, this q value that you guys were talking about, right?
Yes.
Okay. It takes the whole graph and it moves it up by 2. So where our asymptote was originally on the x-axis, our asymptote is now at 2, because that plus 2 took our whole graph and moved it up by 2.
So when the asymptote moves that line, ma'am, by 2, the other one, the other line that you sketch, it will start on the number that has moved the graph, the whole graph up.
Yes. Oh no, you mean this one here? This one?
Yes, ma'am.
No. This one is it's just a coincidence. It's just because of how we drew the graph. It just happened to start there. Okay. It just happened to start there. It doesn't mean that it will always happen like that. It's just that this graph that we grew starts there.
Oh, okay, ma'am.
Okay. It's not always going to be like that. Okay.
Yes, ma'am.
I'll show you another example just now. Okay, Nolwazi?
Yes, ma'am.
All right. Mawande, I'm going to need you to focus on the lesson for me, please. Okay. All right. I'm going to ask you guys quickly to use the two things that we know, and I want you guys to draw this graph. 3 to the power of x plus 1. Plus 1. All right, let me remove all my other stuff. All right, tell me what the asymptote is, and then find me the y-intercept. Okay. Good. My asymptote is 1. And find me the y-intercept, guys. When x is equal to 0, what is y equal to? While I take Sibahle's question. Sibahle, what's up?
Ma'am, I still don't understand the bottom graph below the asymptote. Yes. Why is it at 1?
Okay, so remember we want the y-intercept. What do we do at the y-intercept, Sibahle? We make x equal to
0.
0. Yes. So if I put 0 into this graph, I'm going to get negative 2 to the power of 0 plus 2. What is 2 to the power of 0 equal to?
It's negative 2.
Just 2 to the power of 0. Anything to the power of 0 is equal to 1. Yes?
Not 0. Okay.
So it's not negative 2. It's going to be negative 1, because 2 to the power of 0 is 1.
Okay.
So I'm going to get negative 1 plus 2. What is negative 1 plus 2?
It's -1 plus 2. That's great, ma'am. I'm lost.
Okay, you just need to answer this question for me, Masudi. What is -1 plus 2?
It's 1.
It's 1. The answer is 1. And that's why this graph here at the bottom cuts there.
Oh, okay.
Because our y-intercept is at the point 1.
Okay, I get it. Thank you.
Okay, you're very welcome, my sweetie. Okay. All right. Okay, I want us to just have a look at this next graph. Karabo, I'm going to need you to unmute for me, my sweetie, because you keep putting your hand up and I'm asking you to unmute and you're not unmuting. So I need you to just unmute for me, please. Buntle, what's up?
Ma'am, I wanted to ask if, like, is it really necessary that we draw those two lines on the same graph, like we plot them on the same graph? Is it very necessary?
You mean both graphs or which two lines? The green one, the purple one, the blue one?
Yeah, the green one, the blue one and the purple one. That's what I mean.
No, my sweetie. The only reason I've drawn both of them here is because we're comparing the two graphs. Normally, they will only ask you to plot one graph. Okay, one exponential. Okay. All right. Excellent. Is the asymptote always in the y-axis? Yes, Maya. In an exponential graph, it's always in the y-axis. Okay, always this way, always horizontal. Okay, all right. I saw a lot of 5s and 7s and 9.9s and 10s. So I think most of us are on the right track. If you're at a 5 or a 6 or a 7, what you need to do is do examples. Okay, you need to do examples. For those of you who are still at a 2 or a 3, I need you guys to rewatch this video. Okay, it's quite important that we rewatch the video just to make sure that we are understanding the concept. The nice thing about the videos is that we can pause and look at what ma'am's doing. We can rewind and listen to ma'am's explanation again. And all of those things. Amohelang, the dotted line is the asymptote. This is the line that my graph cannot touch. Kanyisile, the asymptote is vertical in a hyperbola, in one of these graphs, these ones. Okay, that's the vertical asymptote. And this is the asymptote of x. Okay. That's the right attitude, Tawang. That's it. All right, teacher Nels, I'm going to ask you to put up the hey guys, English, the English is not Englishing. Okay. Yes, the pace poll, that's it, the pace poll. Please let me know how we did. Okay, Karabo, what's up?
Hi, ma'am.
Oh, there we go, Karabo, yay, what's up?
Hi, ma'am. I just wanted to ask you a question that if you are writing a test and then they ask you to write an equation, is this how you're gonna write the equation so that you can draw the graph?
No. What we're doing now, Karabo, is they are giving us the equation and we are drawing it. Okay. They give us the equation and we have to sketch it. In next week's lessons, we will be learning about when they give us the graph and we have to give them the equation.
Okay.
Okay.